Hi, we are going to do the argument of a complex number. Let us start with the Argand diagram. This is something that this area covered. In this Argand plane, x-axis represents the real axis and y-axis represents the imaginary axis. And this point P represents a complex number. PAB is a complex number which is equal to A plus iota B, where A is the real part and B is the imaginary part, and B is associated with iota. So this again can be written as the general form of a complex number, which is Z is equal to A plus iota B. The triangle OPM is a right angled triangle, right angled at M. Angle POM is equal to theta. Theta is any angle. So OM represents the real part, which is A. So this is of length A. So OM is equal to A. In the same way, PM represents the imaginary part, because this is parallel to y-axis or representing some point on the y-axis, and we see the imaginary part is B. So length of PM is equal to B. The length of OP is, let it be R. So let OP is equal to R. Why we are making all these things will be clear very soon. We have to find the argument of a complex number which is actually equal to theta. Theta is called the argument of the complex number, which is very simple. The angle POM is actually the argument of the complex number, but we have to find the value of this theta. To find the value of this theta, let's see how we can find the value of theta. Before finding the value of theta, we need to know something about sine theta. In your basic trigonometry class, you know that sine theta is actually equal to perpendicular upon hypotenuse. Perpendicular upon hypotenuse. So in the triangle OPM, which is right angled at M, the perpendicular is the B, length B, so because PM is equal to B, so perpendicular is B upon hypotenuse. Here hypotenuse is OP, R. Now from here we can find the value of B. So B is equal to, we can do the cross multiplication of sine theta and R to find the value of B. So B is equal to sine theta multiplied by R. So this is R sine theta. Now see what is cos theta. Cos theta is equal to base upon hypotenuse. In the same triangle, base is the length OM, which is A, and hypotenuse again is R. So A is equal to cos theta multiplied by R. So it is R cos theta. Finally, we got the value of A and the value of B. Since we know the value of A and B, now this complex number A plus IB can be written as A, which is equal to R cos theta, plus B, which is R sin theta. So this is I R sin theta, and we take this R common and we can write cos theta plus I sin theta. This particular form is known as the polar form. So a new form to write a complex number, which is z is equal to r cos theta plus I sin theta. A is equal to r cos theta, B is equal to r sin theta, and complex number is written in a new form, which is the polar form. So what all important things are there in this polar form is the value of r and the value of theta. We know the value of A and B, so r is equal to, we see OP is equal to R. So what is OP or what is R is actually under root A square plus B square, that is base square plus perpendicular square from the Pythagoras theorem. We can recheck it. We can put the value of A, what we have found it here, A is equal to r cos theta, so we can write r cos theta whole square plus B is r sin theta whole square, which is equal to under root r square cos square theta plus r square sin square theta is equal to, r square is common, and then we have cos square theta plus sin square theta. We know cos square theta plus sin square theta is equal to 1, so under root r square is equal to r. By using the Pythagoras theorem, we see hypotenuse, the length of hypotenuse is r. This r is called the modulus of a complex number, or mod z is equal to r. So in the polar form of a complex number, which is z is equal to r cos theta plus I sin theta, this r is actually modulus of z. So again we can write the complex number in this form. We just replace r by mod z, which is the same. To find the value of theta, let's first take tan theta. Tan theta is equal to perpendicular upon base. So this is the perpendicular and this is the base. So perpendicular is B and base is A. Now theta is equal to tan inverse B upon A. So this tan inverse B upon A gives the value of theta, which is called the argument of a complex number, argument of z. Now let us do a question where we will find the polar form of the complex number, and we will find actually the value of r and theta. Suppose the complex number is 3 minus 2 iota. So z is given 3 minus 2 iota. So write this in the polar form. In the polar form, two things are important. We need to know the value of theta, and we need to know the value of r, which is mod z. So mod z is actually equal to under root real part of z square plus imaginary part of z square. If z is equal to a plus ib, so mod z will be under root a square plus b square. It is as simple as that. So we will find z here is equal to under root a square plus b square. So a is 3 and b is minus 2. So 3 square plus minus 2 square is equal to under root 9 plus 4 is equal to under root 13. Now let's find the value of theta. Theta is equal to tan inverse b by a, which is tan inverse b is minus 2 upon 3. So theta is tan inverse minus 2 upon 3. The complex number z, 3 minus 2 iota, can be written as r into cos theta plus I sin theta, which is into cos tan inverse minus 2 upon 3 plus I sin tan inverse minus 2 upon 3. So this way we can solve. So first we have to find the modulus, and then we will have to find theta, and we can use this general form and put the values in it. Thanks very much. I hope you have liked this video. Please like the video and please subscribe to our channel CBSE Plus.